Hello everyone, in this tutorial we're going to be taking a look at collision detection. Now in order for us to do this we need a scene with some items in that can collide with each other. So first of all I'm going to drag my background sprite into the scene, and this creates a scene object which we will name background, and then we're going to go to the sprite and set it to layer 5. This just makes sure it is behind everything else in the scene as it is our background. So the next thing we need is something that can move in order to cause a collision. So I'm going to just use the procedural square sprite for this. So I just click add new scene object. And of course this being on layer 1 will be rendered in front of the background. So we'll just put that there. And we'll also set its position to 0, 0. There we go. And we will call this square. So now we have our two objects. We also need some objects that we can collide with. And I think we're going to collide with these nice stars. So I'm just going to drag a few of these in here. I'm not going to bother naming them. We're just going to drag 1, 2. We'll go with 3. 3 is a good number. Okay, so the next thing we need to do is give this white square the ability to move whenever we click. So in this case, the background object is going to be receiving the clicks. And actually, we've just forgot to set that to 0, 0. So I'll quickly go ahead and do that. So we need to go to the background object, functions, on mouse down. Now, the first thing we need to do is get the coordinates that the user clicked. So we are going to write var position equals data. Now this is what is passed to the event when a click happens. Dot screen position. There we go. So now position is an object with x and y values for where the click occurred. And that is where we want to move our square to. So all we have to do is write Wade.get scene object, the name of our square, which is just square, and then move to, and then we put in our coordinates. So position.x, position.y. I'll just make this a bit bigger so it's easier for you to see. And then a speed, and we're just going to go with 200. So if I save that and then run the project, when I click on the background, we see the square moves. Now we also see these stars are kind of a bit hard to see, so I'm going to move them a bit closer into the middle there. And I'm going to make them a bit smaller. They can be different sizes, it doesn't really matter too much right now. So we'll just position them around the place like that. So if we run it again, there we go, we can see we've got all these stars. Now, of course, if my white square goes to the star, nothing happens, it doesn't collide or anything. That's because we've not written the code to handle that yet. So, for our square, we are going to select it, we are going to go to functions, and then we are going to go all the way to the onUpdate function. Now, this is the easiest way to do it, but not necessarily the best, because onUpdate is run very, very frequently. It's basically run every simulation step of your program. So if you're putting something that has to do a lot of work in there, you might want to rethink it, try and work around it if you can, but for our purposes, it should work perfectly fine. So the main function that we are interested in is this.get overlapping scene objects. What that does is it returns a list of all the objects that are overlapping with your current scene object. So we're going to store these in a variable called objects, which equals this.get overlapping objects. Now in here we have two possible parameters, though in this case we're going to use the default values. The first one is search all layers. So do you want to check if you're overlapping with objects on a different layer? In this case no, because the square and the stars are on the same layer. And the second one is if you want to take into account the rotation of objects and things like that. So that's if you want a more precise collision. And you've got two options you can pass into that, either oriented, which is one of them, or axis aligned. So we are just going to use the default values, which means we do not need to enter either. And that will give us a list of objects we are colliding with. So because we could potentially be colliding with more than one object a frame, though it's unlikely, we are going to create a for loop. So for var I equals 0, while I is less than objects.length, because objects is always going to be an array in this case, I++. So if we get into this for loop, we have collided with an object, and for now we're just going to remove that object. So we can do Wade.remove scene object, objects I, which is the current object, and we'll just put our colon there. So let's see how that runs. So we run the program, we can still move our square. Can we collide with the stars? Yes, and indeed they disappear. So every single frame we are checking if there are any overlapping objects, and if there are, we are removing from the scene. That is not amazingly efficient, but it works reasonably well most of the time. However, if you can, you should limit the amount you use get overlapping objects, because if you've got a scene with 100 or 1,000 objects, you could potentially be checking thousands and thousands of things every second, which it's a bit of a drain on slower devices, so you want to try and optimize it if you can. But that's the basic principle. I'm just going to go collect all these stars because it's fun. And in a very simple game, like, I don't know if you've played the very old-fashioned apple catcher or similar games, all you would go around is collecting things. So in the collision function, you could just add scores, like you collect coins if you were playing Sonic, for example, and similar like that. So there's the collision detection, which Wade does pretty much automatically for you, and there's the collision response, which is what we just did inside our for loop. Now, in addition to this, Wade does have a physics plugin which handles collisions that are quite a bit more complicated. It can make things bounce off at angles, so if you were going to program, say, an Angry Birds clone, it would be a good choice for that. And it provides things like static friction, dynamic friction, inertia, mass, or everything you need to create a much more realistic physics simulation. So if you've got more complex needs, you would probably want to consider taking a look at that.